So today is our last lecture for summer quarter, and I'm going to spend a few minutes talking about collections, generics specifically. I provided a general introduction to how to choose a collection last time. And then we're going to move into three small advanced topics, JNI, reflections, and multi-threading, and talk about your final. So, good evening all. I've been getting a few questions on assignment 6. So in assignment 6, you're supposed to create a student data class that contains student and statistics. And then you're supposed to make an array of student data and persist that to this. And then you're supposed to read the data, read the serialized file, you're supposed to read the serialized file and print information using methods declared in the interface. So this is just to help clarify what's to be done in lab 6. So last time on collections, we talked about how to choose a data type. So collections in Java is a memory management mechanism. And so depending on the requirements, data can be accessed quickly. And there are a variety of factors that impact. So choice of a collection is impacted by size, usage, meaning read versus write. Are you writing more records or reading more records? We also have contiguous versus, so there are some systematic system things. Contiguous versus discontiguous memory. And then all the algorithms, whether we're talking about hashing, using trees, using a set or a map or a list. So when collections are implemented, so pre-template days, um, each object that was saved in a collection was of type object. So everything was treated as an object. And that kind of makes the life a little bit hard in that you have to, when a type is retrieved from a collection, you have to figure out the data type. So that makes the usage very slow. But yet, when we make an array list or a linked list or whatever, it can be of different types. So the object type now is defined when a collection is declared. So we can say we want a collection of student data or a collection of statistics or whatever type, just to use some examples from lab 6. Okay. So what are generics? It's basically a type definition of a variable or variables declared in a class in runtime. So let's pick some examples from um, the website to go over this. Okay, that file should be visible to you guys now. So this is what we are talking about. When we declare a class, we define a type in angle brackets like this. So T is a type that we can specify, and it has to be, it can be any class type. It can't be a primitive data type like an int or a float, etc. And then we declare an object of that type. We can initialize. We can write a getter setter, and then just to demonstrate a simple template, we can show the data type of that. We can show the data type of whatever type that was declared as T. So then how does that work? Well, you can see that an object is declared, and in angle brackets, we end up specifying integer. So when integer is specified, we create a new object and pass 88 into that to declare our integer. Then when we call the show type, it's going to show an integer. We can also get the value of the int because we have a get method, and then print the value out. The same object can be, the same type can be used for declaring the same type can be used for declaring a string. And then of course, when we call the show type method, it'll print a string, and it'll call get ob, and it'll retrieve the value of the string and will print it out. So this kind of provides an introduction to a basic template. The idea is repeated in the second example, that in those angle brackets, we end up specifying two types. So there is really no limit on the number of types that you can declare. So T and V can be any type of objects. So the constructor, initialization, the show type, and the getter methods. So the demonstration of the second template is passing in two values, and those can be any types essentially. And then we print the show type, or we call the show types method, and we call get ob1 and get ob2, the two types, and print their respective values out. Okay. So the next one takes us a little bit further, and we say T extends number. So what we are trying to do with extends inside the type definition is limit the access to so as long as T is a type of child, T is a type, T is a child of number, excuse me, it will be accepted in stats. If it's not a child of number, then it will not be accepted. Okay. So we can go in and initialize stats by passing in an array. So whatever is specified is, whatever argument is to be passed in is specified in the constructor. Then we compute the average using method and print it out. So this one example, what it's trying to demonstrate is one, if you're trying to work with different data types, there's no need to overload a set of methods for the same functionality. We can basically use the same method. In this case, average, to compute the average value. So we start with an integer array. So we pass in inum, which you can see is an array of 5 values. We then compute the average by calling the average method that you see on the top. And then we print out the average. Then we follow along with the double data type doing the same thing. We declare a double array. We compute the, we instantiate the object, compute the average, and print out the value of average. The last part shows trying to pass in a bunch of strings into this, and that basically won't compile because it's expecting an array of integers, and it's expecting an array or a data type that's a child of number, and string is not. So that won't essentially work. Okay. So this is a demonstration of templates, if you will. where we are somewhat restricting access to a data type. Now, the reason we need to know all this is because when you guys work with collections in advanced Java, you have to know the collections. I mean, you have to know how the generics are implemented, because generics are used for coding with different collections. So learning how the code works is very important. In this example, we have the exact same thing, except there is a new concept that's introduced. Stats with a question mark. This is a wildcard that is basically used to, and this is usually used at a method within a template definition. From the previous example, you might recall we've got T as a type number, right? So when we specify the data type here for comparing, this question mark basically means that whatever type is passed here should be a child of number. Okay? It should be a child of number. So we go through the entire demonstration like we did in the previous example with integer, float, and integer, float, and doubles. All of that code would work just fine. So now when it's time to compare averages between different outputs, we can say IOB has same average as DOB. DOB is doubles, IOB is integer. Okay. And we are also comparing this with integer average with float average. So that gives you a gentle introduction to generics. So to get a little bit of a perspective on how generics are used with collections, this is how we declare a array list. So collections we get to know are array list, linked list, hash set, hash map. We also have to learn tree set and tree map. Do you guys recall me covering hashing last time? Does everyone understand what hashing is all about? People in the room, can you hear me? Does anybody remember me covering hashing last time? Okay. Well, covering you should know hashing. If you look at my notes from last time, that'll be a good reminder. There is the notes from August 1st. And you have some notes here from last time. So these are things to know, okay? If you do not remember, I request looking at the lecture from last time, please. Okay? Okay, so these are some of the collections, and I'm going to show you some examples. I don't expect you guys, for exam purposes, to be able to code using collections. I mean, if you can, that's wonderful. But that's not an expectation. Okay? So you should know collection concepts, like I covered last time, and you should know how to be able to you're going to be tested on collections. I'm going to cover the collection concepts that I covered last time, how to code with generics. But the specific, like the example I'm showing you right now, how to code with a specific collection, I'm not going to ask you those questions like create an array list of this data type or something like that. I'm not going to ask you guys to do that. Does that make sense? So then let's look through a couple of, let's look through a few examples just for fun. We create an array list of strings, and then we add two values. And then if we try to add a date data type, that won't work because we're expecting only strings. So then we can attach an iterator. And we can print each value in the array list. We don't have to use an iterator. We can also use the index value of an array list. If you recall, ArrayList was ArrayList is like array except it's expandable, right? So this next example we're going to look at is talking about the speed of ArrayList versus linked list. So we're trying to basically test how long something takes, right? For inserting values. So we start our timer. We basically say int start, and then we go and look at the time, the current time in milliseconds from the system. That's reading from the system clock. Then we create an object and we go ahead and we add the object into the list. This is an older way of programming working with collections. So whatever size we decide, we add the items and then we return system.current time milliseconds minus start. If you run this program, you'll see that linked list is faster than ArrayList, because in ArrayList, the value is added in the end. In an ArrayList, the value is added in the end. So it takes longer. Linked list, memory is allocated anywhere, so it runs a little bit faster. If you are trying to add objects to the end of the list, now that will take a little bit longer. So with linked list, what is the cost here is the traversal. Traversing the entire list to get to the end of the list to add the value. Whereas with array, it's faster. So it's the same thing, same as previous example, except it's adding to the end of the list. Okay. So this is just a usage of an array list. Here we create an array of strings. and we make a array list of planets, and we add each element of the string into the array. Then this begins to show you how the API works, right? Sorry, I wasn't ignoring all the questions in the room. I'll answer those if needed. I'll answer those in a minute. Let me just cover the topic, okay? So here we are looking at the API for array list, and we associate a list iterator. So when we call lit.next, we are essentially moving the iterator from the first node to the second node. Then we go in and read the value. We can also remove a value. So the structure remains contiguous. And then going out after 3 more values. And then we can add a value. So you're going to find create, read, update, delete operations that are all available in the API for us to use. So going to the previous node, removing a node, those methods are demonstrated here. So guys, you will be tested on collections. You'll be tested mostly on concepts, and you're also going to be tested on the coding for templates, generics. The 4 examples that I covered at the very beginning of today's lecture. The examples that I'm showing you now, where you're coding maybe with maybe a specific collection, you won't be tested on. Okay. Now, if it doesn't make sense, please let me know. I'm happy to answer any questions you may have. Okay. Okay, let's talk about some of the other advanced topics. There are a lot more of these examples, as you can see, but starting with say array list and linked list, that would, just starting with those would suffice. You will need to explain the concepts, I won't ask you to apply, but you should be able to read the code for coding with generics. Okay? Like the simple examples I showed you. All right. So the next topic is Java native interfaces. So I'm going to look at JNI slide deck from the website. I'm sorry, these pages are having trouble with specific documents. This really slows us down a little bit. When you guys click on that, these files, do you get a file not found issue, or does it work? These notes you should have at your disposal. Okay. So I'm updating the links as we speak. So all three files should not give the file not found error anymore. It should work for you guys. Okay. Yeah, it's downloading for me flawlessly now. Also. So we can look at Java native interfaces. This is an API that was added in the Java language for it to interact with C++ and C-like interfaces, or C++ or C-like languages. Okay. So it's a standard that allows for embedding native methods inside JVM, or providing a way for C++ libraries to call the Java programs. So primary goal is binary compatibility with native method libraries. So this picture shows the Java environment, and you've basically got your local classes that you load, and it takes the code through the class loader and then the bytecode verifier. Class loader simply loads the class in memory. The bytecode verifier ensures the integrity of the binary file. It ensures the integrity of the binary files, the code that is written, because the class file can be altered. Class file can be altered, and it ensures that if the file has been altered, that doesn't load. It also ensures that the rules for the syntax are indeed followed. Then we have the JIT compiler, the JIT compiler. that is also referred to as the just-in-time compiler, and the job of JIT is to essentially optimize the code for execution. It will eliminate code fragments to run those faster. Then we have the bytecode interpreter. This is what converts the portable code to machine code to execute. Now, the reason I'm bringing this picture up is because we've got the native stack here. So from the Java program, if I'm trying to interact with the outside world of the operating system, like in C++ or C programming languages, then I can do so easily with the JNI bridge. Other things that are in the picture, like the Java heap, which is where most of the memory is allocated. We've also got the user and system thread, which are basically like the main thread or the garbage collection thread that's running. Method area, that is for all the static memory area. Let's take a few minutes to see how native JNI works. So if we write a code, if you write a piece of code snippet that we expect for Java to basically find outside of the runtime environment, like in this case, we are trying to write a method called say hello, that would be written in C or C++ language. So then that method is declared native in the class and then compiled. If we end up writing programs in JNI, that would essentially mean that the write once run anywhere feature that Java provides is essentially lost. With JNI, the elements of encapsulation are not respected, if you will. You have to also do manual garbage collection. And if we, with JNI, if we end up working with languages that are not object oriented, that would also mean that we essentially lose the O control or object oriented design that we have tried to set up. Okay. So anyway, there is the native method, and if we say have this method called say hello, then we also have a method called speak up, which calls the say hello method, and then there is also a simple print line method or call to print line that's done in the speak up method. Kind of a quick way of testing, if you will. So what we do is we compile the class, and then we use this command, java h minus jni, and what that does is it generates the header file. Okay. So when the header file is generated, we take that. This is what the header file looks like. We basically take this and we include it in our C++ file, and we write our code in that. The say hello method is written in the say hello method is written in C++. So what's going on in this method is we are making some calls to predefined methods like getString, UTF-chars. The getString UTF-chars is going into the Java environment env, and it's reading the string message that was passed into the function, starting with location 0. And it stores it in a local string. It prints that string using a printf function in C. And then it releases that memory. Remember manual garbage collection? It basically does that. This code is then compiled. So those of you who may have done native programming with C or C++, you can create a shared object like a .so file, or you can create a .dll depending on Unix or Windows. So these are just instructions for how to compile those files. And then once the object is created, we go ahead and we load the library. So we have a static block here, which means it'll be the first thing that will be loaded. So we load the library and then we call the speakup method. To refresh your memory, the speakup method was in the very beginning, and it called the print line function, and it also called the native function. Okay. So these are like all the steps we take to write a program with JNI. Okay. So JNI provides binary compatibility. Let's take a 10-minute break. Well, a real world application is when you open a socket from a Java program. It has to interact with the operating system. For you to make that system call in native environment, you would use JNI. Okay. So we'll come back in 10 minutes and continue with reflections and then multi-threading. All right, folks, back in 10. Thank you. So the next thing we're going to talk about is reflections. Reflection is an API that allows for an object to look like if we have an object and we can find all the properties of that object using reflections. So in a nutshell, reflection APIs allows us to find class information, interfaces, and objects in the current JVM. So you guys are working with serialization. You've got say a student object. If we want embedded in student object is all this information. So if we apply the reflection API to the student object, we can find the name of the class. We can find the class modifiers, like whether it's a public or a protected class. We can find the fields, methods, constructors, and superclasses. We can create a instance of that object, like if we wanted to create a copy of it. We can find interfaces it implements, methods that are declared in the interface, constants that are declared, calling the get and set methods. So all of these things can be done using the Reflections API. So this is a list of all the classes in the Reflection API. We've got a class named class as part of java.lang. There's a class. We also have classes like field, methods, and constructors. Fields, methods, and constructors are for instance variables, methods, and constructors of the then you can see a few more classes like for array, for modifiers, and other things. The question is, how is this API used? So let's say you have a button class, and we had an object of type button. If we wanted to find the name of the class or its superclass, then we can use those methods. So here is just showing those methods in action. Trying to understand modifiers. Whether the class is public, abstract, or final. So we have this method called get modifiers, and then we have methods like is public, is protected, or is final. So you call c.get modifiers and you get a variable. You get an integer value m. So then we can take the value of m and figure out if it's public, protected, or final. We can go ahead and find all the fields associated with a class. So we call the methods get fields that returns an array of all the instance variables. We can call get type and get name to find the data type of each field and name of each field. So that is exemplified here. You can see we call the method get fields, and then for each field name, we go out and get the name and the type. Okay. Similarly, we can go out and find constructors. And we can find the name of the constructor, the modifiers, whether it's public or protected. Constructors are generally public. Parameter types that are passed into and what exceptions are thrown. We can also use constructor.newInstance to create a new object or a copy of that object if we want it. So here is a quick example. So we have call to get the constructors. And then once we get all the constructors, we can go back and find the parameters associated with those constructors. We can find the name of the constructors and print those values out. then the next thing after constructors is methods. So like constructors, we call get constructors. For methods, we call get methods. Then we've got methods to find all this information about the methods. Method name, its return type, parameters passed, set of modifiers, any exceptions that a specific method might throw. And we can call method.invoke to call the method also. So to see this in action, you can see and then once all the methods are retrieved, then we go through a loop and print out all the properties of each method. So we have get interfaces, same thing. So let's talk a tad bit about multi-threading. And then we'll talk a little bit about the final. So multi-threading. In Java, even the Hello World program is running with 2 threads. So we like to say it's multi-thread or dual thread. We've got main and we've got the garbage collection thread. So when multi-threading has to be implemented in a Java-like environment, it has to rely on the underlying operating system. So Java Virtual Machine relies on the operating system for running its threads. The reason we have threads is because with just if everything was single threaded in a in a process, the amount of CPU power we have, we are not able to harness the full usage of it today. So multi-threading helps in doing multiple tasks concurrently. So we have native executables and we have the virtual machines running these programs. Granted, the programs are converted to native mode, but these are this part of the Java virtual machine. It has to, every time it creates a thread, it has to register with the operating system. When the native executable runs, operating system is already aware. So the idea of running things in multiple threads. So what are some good examples that we can show? So let's say I mistype a word in PowerPoint. If if I mistype a word, you'll quickly see this squiggly line underneath. That's a thread that worked to produce that idea. So threads, when we run multiple tasks within a process, we do a lot of context switching. Context switching meaning jumping from one task to another. Threads generally exist within the context of a task or a process. And they're independent execution paths with many threads per process. So there are two new terms that are added for your vocabulary: non-preemptive and preemptive. Non-preemptive are threads that do not give way to other threads, meaning once they have access to the CPU, it will essentially finish the task before relinquishing control of the CPU. And preemptive will always give way to other threads. So if a thread of higher priority comes around, it will yield way to the thread of a higher priority. JVM and packages are thread safe, meaning any of the functions you have can be used in thread. JVM and packages are re-entrant. Re-entrant in the sense that you can carry on forward where you left off. So Java runtime environment generally will use the native OS threads, which means anytime you create a multi-threaded app in Java, which is always the case, it's always going to give control to the operating system to execute. So there are few thread scheduling schemes. We have time slicing and priority based. Time slicing is when a unit amount of time is given to a thread or a process on the CPU. But if you look at Unix-based systems, those implement priority-based, meaning thread of higher priority runs to completion. Java runtime does not implement time slicing. It uses priority based. And Java runtime itself is preemptive. Higher priority threads grab the CPU and run. So when we want to do any multi-threading programming with Java, we use the java.lang.thread library. So a thread can be either, when you work with the thread class, it gives you all the functionality to create a thread. Thread can have 4 states: spawned, running, blocked, and dead. Threads does support priorities. It does support synchronization, although priorities in Java are just for namesake. It's not real. Synchronization, exclusive access to a resource. So just like, you might have a tunnel through which only a single train can pass at a time, then each train gets synchronized access to the tunnel. So there are no collisions. Just to kind of visualize an example. And then threading support is built in this object, java.lang.object, with wait, notify, and notify all. These are some of the methods. So to understand thread lifecycle a little bit more, let's look at this slide. So we create a new thread, then that's considered to be spawned. Then the thread is started. It's considered in the running state. And then if the thread sleeps, yields, or waits, then it goes into a block state. And then when the thread is done running, it's considered to be dead, basically. So to create a thread, you can extend the class. You can either extend the thread class or implement the runnable interface to create the thread. So this is just, again, a small introduction on multi-threading. This will be covered in more depth in the next course. I will probably ask you about concept questions on multi-threading, but nothing on coding side. Let's talk about your final. Your final will be from 6 to 7:30 p.m. on Wednesday, August 8th. I'll plan to give you 6 questions, maybe a choice of, maybe from a choice of 8, and I'll take the best 6. So if you answer more than 6, that's fine, but you know, I'll take the best 6. %80 of questions will be on material covered after the midterm. %20 of questions will be on material covered before the midterm. You can expect the exam will be comprehensive, so you can expect concept questions. You can expect concept questions. You can expect reading, writing code. So no multiple choice questions. Open book and notes. And I will be emailing you the exam a few minutes before the start time. So exams are emailed to me at cislabs05@gmail.com. Okay. So any questions about the final, please let me know. What is the breakdown of concepts versus read write? I don't know. I'd say probably you might get 1 to 2 questions on reading, writing code, and the rest on, writing code. Majority will be writing code. So for the final, will we be expected to be able to write code on concepts covered in assignments and to explain concepts covered both in assignments and after? Yes, correct. Study guide. The study guide is basically the my notes that I'm showing here. All these things that you see here, all the basically PowerPoints and all that, Okay, so yeah, that's always available. All right, folks, it was good having you in the course. I hope you had as much fun as I did. And we'll be ready for the final on Wednesday. And if you guys have questions on Lab 6, stick around. I'll answer those for you in the end. And have a wonderful evening, everyone. Take care.